Hello everyone, welcome back to the another session, and this video is about quicksort. Let's understand what is quicksort and what is the analysis of quicksort algorithm in this video. Okay, now let's start. So it is also an example of divide and conquer strategy. So we already come across in the previous video to learn about what is divide and conquer. That will divide the whole problem into sub problems and will conquer each problem, then we'll combine it. So this is what divide and conquer strategy. Now, as far as quicksort is concerned, this is also called as partition sorting algorithm. Quicksort is also called as partition sorting algorithm. So the algorithm will go like this. The procedure will go like this. We will be considered one element as pivot element. So that means if we have this list of elements to be sorted using quicksort algorithm, we have to consider one of the element as pivot element. One of the element as pivot element. Now, this pivot element can be beginning of the list, or else the pivot element can be middle of the list, or else the pivot element can be last of the list. So you can consider any element as pivot element. Okay, so that is what the first step in the quicksort. Now, how to select the pivot element is we were done. After you consider the pivot element, let us suppose I have taken first element as the pivot element. If my first element is the pivot element, so pivot element will be arranged like this, that if it is my first element, then the left side of pivot element should be lesser values of pivot. The right side of pivot element should be greater than of pivot. And this is the way how we will sort using quicksort algorithm. Let us suppose that I have taken pivot as 10. Then what we'll do is we will find the best place of this 10 first of all. So greater elements of 10 should be available at right hand side. Lesser elements of 10 should be available at left side of this pivot. If you arrange this list, then the list will be something like this, right? So that is what 10 will be settled here, and this is what pivot element. All the lesser elements than 10 will be at left side. All the greater element will be at right side. And as of the first step in the quicksort, first procedure is we'll find the correct place of pivot. That means the list will not get sorted. In the first procedure, we will find the correct place. Second, we'll apply the divide and conquer to sort the elements. Okay, how to select this place or how to fix this place, otherwise how to find the place of pivot, that is will go something like this. So this is my list. Example, this is my list. So in this list I am considering 10 as my pivot. Now index of this list will start something like L in the sense low index, H in the sense high index. Okay, this is infinite, high index. Now, your elements were started from low to high. So, this index I am calling as I, and this side I am calling as J. Why? The only reason is once after we choose the right place of this, left of pivot element should be lesser, right of pivot element should be greater. So what we'll do is we'll increment I until we find greater than pivot. Did you understand? Now let's see. So now my first element is 10. After this 10 I have 16. So that means this is right place. If it is
if it is my pivot element. So after 10 I should have greatest element of 10. So 16 is in the right place. How it is right place? Because 16 is greater than 10, so it should be available right hand side of 10. Now increase the index. So I value will move to 16. Fine. Now, now again we'll move I value to here. Now let's suppose we were here. What we'll do again, we'll check with the pivot element whether it is lesser or greater. So when you check this, and we'll be doing here, right, and the same we'll be doing from this side also, we'll decrease the j until we find smaller than pivot. Will increase here and will from this side will decrease, and so we will be comparing with the 16 and we feel it is right place. Again we will be comparing with 8, so it should be of left side. So what we'll do is we will come from this j loop also. We used to compare this, and what the comparison 10 9 5. So 5 is what greater, I mean 5 should be what less than of this. So what we'll do is we'll just shift the places of this, right? We'll shift the places of 5 and the 10. So now here we will go something like this. You can see here. So we'll search the right place for pivot element. So first comparison will be 10 greater 16, that is of second element. 10 less than 5, that is of j index side. So now what we'll do is we'll swap the element. Okay, now if you see this one, 10 greater 16, now it is right place I said. 10 less than 5. So 5 should be, it should actually it is at right hand side. It should not be right hand side, the wrong place this one. Because after 10 there should be all greater elements, but we could able to find it is smaller. So swap it. What the element has to be swapped? Now we will swap 16 versus 5. So here itself updated with 5, then here we'll updated with 6. Correct? Now what we'll do, we'll increment the indexes. Done. Now let's have a look here. So after you swap this one, 10 will be here, 5 and 16 places were changed, and we will be going the same procedure till you found the correct place. Now what we'll do is we'll increase I and we'll check again, and it is also lesser element. 8 should not be here. Again what we'll do, we will be coming from this side, it is a greater element. Now what we'll do is it is a right place. Again increment I, we'll go till j crosses I. Now this is the place where I is moving and j is also moving from this, and the indexes has been changed, that is I has crossed j. When it is happened, now we have to fix the j location for the pivot element. So after you complete this task, we will get the location something like this. Done. So 6 place will be given to 10, 10 place will be given to j. Now the list will be 6, 5, 8, 9, 3 and 10, 15, 12, 16. So if you look at this, this is what the first procedure. Now in the first procedure, we could able to find the correct place of pivot. సో ఇప్పటిదాకా మనం ఏం చేసినామంటే పివోట్కి ప్లేస్ని సెట్ చేసినాం. మనం ఇంకా సార్టింగ్ మొదలు పెట్టలేదు, ఖాళీ పివోట్ని సెట్ చేసాం. సో నా బిఫోర్ ఆఫ్ దిస్ పివోట్ ఇట్ ఈస్ పార్టీషియన్ 1, ఆఫ్టర్ ఆఫ్ దిస్ పివోట్ ఇట్ ఈస్ పార్టీషియన్ 2. Now we have to apply quick sort. So what is quick sort? Whatever we did, that will be repeated for this partition. What we did, we again consider 6 as the pivot, right? Now again we'll compare. So 5 versus 3 will compare. Partition L comma H, pivot A comma L. The lowest element is my pivot. I is equal to L, J is equal to H. Now this will be goes, the loop will get repeats until I crosses J. Now we'll increase this till we found lesser of pivot, and we'll decrease J till you meet greater of the pivot, and we'll swap when it is lesser, right? And this is the task what we will repeat. So this is what actually
quicksort algorithm, and this is what the function calling, right? So now let's see analysis to calculate the complexity. So generally, what is analysis of quicksort? We will analyze how it will be working. Fine. Let us consider 1 to 15 elements. Now, 1 to 15 elements, one element is pivot element, correct? And that is of middle element will be the pivot. That means we will set the place in between. So before of 8, that means before of this 0 to 6 indexes will be least, and after this will be greater. So 8th is what? My pivot element. So leave this pivot element, come to this list. What the list is? 1 to 7 is one partition, 9 to 15 is another partition. Now again in 1 to 7, fourth place is given for pivot element. Now 1 to 3 will be what? Second partition, right? Now leave the fourth element because it is the right place of pivot. Don't do anything for this element. Now fifth element to seventh is what? You have to apply quicksort. Now again 1 to 3, leave second element, you will get one element, and this is what divide and conquer. We were divided the whole problem into sub problems and we are conquering individually. So here you left with one element, here we left with two elements. Now what we'll do is, we will be checking these two elements whether those are in right place or not, right? And we'll do this procedure for the all the elements. Done? Now, so when you have n elements, we divided into n by 2, right? This is one part, this is one part. So now, this again n by 2, it is of n here, and here it is of n by 2, and again here it is of n by 2 by 2, here it is of n by 2 by 2 by 2. So now what is this? Finally, if I got one element, then it will be what? N is equal to 2 power k equal to 1. That is of n is equal to 2 power k is equal to log n base 2. So log n levels n time into log n, that is of the best case complexity, big O n log n. I'm sorry, the complexity of quicksort is big O of n log n. Fine. Now, so here the best case means partition is always in the middle part. If it is a worst case, that is a sorted list. Worst case means sorted list. So in this sorted list, we are assuming T2 as pivot element. So the complexity will be big O of n square. Done? So this is what actually quicksort, how we will be doing it. You just execute the program and you just take the example and follow this algorithm to divide the list. Right? Thank you.